Hello everyone. My name is Krunal. I am a final year student at the Department of Chemical Engineering at VNIT. I am here to give a presentation. But before I drag you into a very boring presentation, I would like to show you a couple of pictures just to make it a little interesting. So let's get started. So this is a snapshot taken from a show that used to come up on the Discovery Channel. The name of the show is Man vs. Wild, and the man you can see in this picture is none other than Bear Grylls. He is demonstrating how well a cold cloth can be used to keep yourselves warm. So he's holding a cold shirt, his t-shirt basically, which is colder compared to his warm body. So this is a view of the thermal camera. Now let's move to the next image. Now this is a snapshot taken from one of the promotional videos of the movie Uri. This demonstrates how night vision cameras are used in the military operations. This is a night vision image in which you can see two soldiers on either sides of the frame, dragging on, crawling on the ground. So let's move on to the next image. Now this is a snapshot taken from a video posted by a YouTube channel called the National Geographic Channel Wild. This was to show how snakes like pythons and pit vipers have a sense to somehow detect hot objects. Now in the image you can see that there are three balloons hanging. One is somewhat black, one is somewhat pinkish in color, and the other is glowing yellow. The yellow one is the hottest one, and somehow this python, which you could see on the image, is somehow detecting, and it gets attracted towards the warmer balloon which is hanging, and that is how these snakes identify their prey. And this is most probably how snakes also view their prey in the dark. So let's move to the next image. This is again a snapshot taken from a YouTube video uploaded by the channel Nat Geo Wild. This demonstrates how the nighttime wildlife observation is done in today's time. Earlier, when I was kid and when we all were kids, night vision, basically nighttime observation of wildlife, was done by shining light on the animals and capturing it through normal conventional cameras, but that used to somewhat alter the natural behavior of animals as the light interacts with them, the animals. But nowadays they use night vision cameras so that the animals' natural behavior at the night time remains unaltered and their natural behaviors come up. So let's move to the next slide. And also on the image you could see a lioness resting in the night time. In the next slide, you could see an image of an African elephant in the night vision as well. Moving to the next image. This is an image of a handheld thermal imager which is pointed towards a booster pump of the thermic fluid circuit. This is the image that I captured myself because this is the equipment that I got an opportunity to use during my internship at an industry. So these thermal imagers, the handheld thermal imagers, are used to scan the surfaces or anything basically, and they give you a thermogram which you can see on the display of the thermal imager, which is nothing but a thermal image of the field of view on which the imager is aimed. So this is the inspiration of my topic for today's presentation, which is thermal imaging cameras. So let's get into the introduction to thermal imaging. Let's get started with the first set of slides. Now, before we get into the topic, we should understand what is a thermal image basically. So we use conventional cameras like the one which I'm using to capture this video to capture images which are called photographs in the visible spectrum of light. But thermal images are captured by thermographic cameras or thermal imaging cameras, which are devices capable of sensing the radiation in the form of infrared light. A thermal image is a digital representation of a scene and a measure of thermal radiation emitted by the pictured objects. Yeah, so what is thermal radiation? Any matter which has a temperature above the absolute zero temperature emits some kind of electromagnetic radiation as a function of its temperature, which is called nothing but the black body radiation. Uh, Something coincidentally and interestingly, any body at room temperature emits radiation around the infrared wavelengths, and this is nothing but what we capture using the thermal imaging cameras. But as the temperature of any object increases, the object begins to emit the light in the visible spectrum, beginning from a dim red glow before reaching a white hot and eventually in the ultraviolet wavelengths and beyond. So how do we detect this thermal radiation that is emitted by the objects which have a certain temperature? So this is done by using sensors called as bolometers. A bolometer is a simple sensor that absorbs thermal radiation and changes resistance as a result. This change in resistance can be electrically measured and the incident radiation can be determined. Now, if we use a single bolometer, then what we would get as a result is nothing but an average temperature of the field of view on which the bolometer is focused. But since we require a thermal image, we use an array of such sensors called microbolometers, which are nothing but small sized bolometers arranged in a particular fashion, horizontal and vertical fashion, so that every small part of the field of view is analyzed differently and their temperatures could be compared with each other, and we could get a thermal image which consists of a foreground, a background, and also the different variations in the temperature in the whole of the field of view. Now let's take a look at a simple working mechanism through a schematic. Yeah, so this is the schematic diagram of a thermal camera. As you can see, there is a crack in the source which emits radiation, infrared radiation in every direction. But whatever infrared energy is emitted that falls in the field of view of the lens is collected through the lens and it is focused onto the detector which is placed on the right side of the lens. But before it gets focused, it is filtered by a filter which passes selected spectral bands only. The IR radiation, after it falls over the detector, it gets converted to an electrical signal. This electrical signal is amplified and processed by the inbuilt processors of the camera. Uh, then it is converted to, these electrical signals are converted to a thermogram which are displayed real time on the display of the camera. Yeah, so this is the same, but I have tried to explain the working mechanism of the each of the components separately here. Capturing is done by the lens, which gathers the infrared radiation from the scene. Detection is done by the sensor, which detects the radiation and converts it to electrical signals. Processing is done by the processor that converts signals to a temperature matrix. The display is used to display the color is used to display the colors to indicate temperature variations. The image calibration is important to ensure the temperature readings are accurate. Let's move to the next slide. Yeah, now that we are clear about the working of the thermal imaging camera, how the thermal image is formed, how it focuses the IR radiation and all, let's look at some important applications of thermal imaging cameras in chemical engineering. In process monitoring it is used to monitor reactors, distillation columns, and heat exchangers for hotspots and inefficiencies. In leak detections, it is used to identify leaks in pipelines and storage tanks by detecting temperature anomalies. In equipment inspection, thermal imaging cameras can be used to detect wear or insulation issues in the equipment like pumps, motors, and compressors. In safety monitoring, it is used to assess potential hazards due to the overheating or thermal runaway reactions. So these were the crucial applications of thermal imaging cameras in chemical engineering sector. But other than this, as you have already seen the pictures that I've shared, the thermal imaging cameras can also be used for surveillance, for night vision, for wildlife observation, and many more applications. So let's move on to the next set of slides. Yeah, now let's discuss some limitations and challenges. The cost is a limitation, which is because the high quality thermal imaging cameras, especially those with cool detectors for greater sensitivity, can be expensive, because these thermal imaging cameras are used to scan hot surfaces and hot areas. So in order to maintain proper operating temperatures for the instruments inside the camera, oftentimes they are required to be cooled, and this whole setup to keep the camera at a certain temperature can be a little costly. So the next point is that they have a limited temperature range. The third thing is the emissivity variations. Now, if we have a thermal imaging camera, it is very obvious that we would use it to scan multiple items or multiple surfaces at a single time. But different materials emit infrared radiation differently. Therefore, there is a requirement for emissivity calibration for accurate temperature readings. Resolution constraints. Thermal cameras typically have a lower resolution compared to visible light cameras. That is another limitation. Yeah. Coming to the manufacturers of thermal imaging cameras, these five are the most famous or most known leading manufacturers in the thermal imaging technology. Out of these, the Fluke Corporation is known for manufacturing the IR temperature thermometers, which were nothing but thermometers similar to which we used during the COVID time to know the temperature of anybody. We used to point it over someone's head and instantly know the temperature, right? So these were those thermometers. Testo SE & Co is the manufacturer which manufactured the handheld thermal imager that I showed you earlier, which I used during my internship. Hikvision is well known for its surveillance cameras, and it also manufactures these thermal imaging cameras. So that is all from my side. Thank you for being such a good audience. Thank you.